Hey everybody, here is a quick run through of how we get the kinematic equations. So a derivation of the equations. It's brief and hopefully should help with give a little background to where they come from. So first things first, we need to understand that these equations are only for use with constant acceleration. So if we draw a velocity versus time graph, a motion with constant acceleration would have a constant slope, okay? And if we are looking at what the average acceleration is during this stretch relative to the acceleration at any given point, we can say that the average is exactly the same as the acceleration at any point. So we can write that as acceleration equals acceleration average. And what does that equal? Well, the definition of acceleration says that it is a change in velocity divided by a change in time. And we can expand that to say final velocity minus initial velocity divided by change in time. I'll leave that as delta t. And so overall, we can say acceleration in general is Vf minus Vi divided by delta t. Now, I leave that delta t in there instead of doing t final minus t initial, just because most of the time you'll be able to either just declare yourself, or the problem will say that the final velocity, that the initial time is 0. All right, so this equation you could say is a mathematical definition of acceleration. This gets rearranged on your equation sheet, the AP equation sheet, to solve for final velocity. And when you rearrange that to solve for final, you end up with final velocity equals initial velocity plus acceleration times time. And this right here ends up being our first equation that we find on the AP equation sheet. And that's pretty much where we get it from. Now, going to the idea of, I believe it's the second one on the sheet. Yes. Actually, this next one is not on the sheet, but it's important to talk about for going forward. So if I was to ask you, how do you find average velocity? We've talked about that in class, and there were a few problems, I believe, on mastering physics. So average velocity is the total displacement divided by the total time. All right. So if you have total displacement and total time, you can find the average velocity. Now, I could ask you another way to find average velocity based just on a motion graph. So again, if we had this set up for a velocity graph, it starts at a low velocity, ends up at a high velocity, speeds up at a constant rate, meaning the acceleration is constant. And I only told you the initial velocity and the final velocity. How could you find the average velocity? If you just had the initial and the final only, no time elements in there. So another way you could do it is to add them up, initial plus final, and just divide by 2. And that's an easy way to get an average of a number, right? So we have two ways now to solve for average velocity. To get to this next equation, we set them equal to each other. So delta x over delta t equals Vi plus Vf divided by 2. If we solve for delta x, we end up with, I'm going to take the half out, Vi plus Vf times t, or delta t, the change in time. And so this is another important equation. However, really all this is is delta x equals average velocity times time. So if you have a constant acceleration, you can use this equation. However, not an equation on the equation sheet. Oh, sorry. Let me get that up into the screen there. All right. So hopefully that makes some sense. Now, for our next equation on the equation sheet, we're going to substitute the first equation into the second equation. So let me show you here. So we have, I'll write them both down again. So we have delta x equals 1/2 VI plus VF. And that was the one we just did, times t. And the other one was VF equals VI plus AT. All right, so we have VF here. If we substitute this quantity in for that VF right there, then we end up with this. So I'll kind of bring these together, and we'll have delta x equals 1/2 VI plus VI plus AT. Put our vectors there, times t. All right, so we can combine. You can go through this. You've all done this before. Combine the v's. 2VI plus AT. I'm going to go step by step here. So and then from there we end up with delta x equals. If you multiply everything out through, we have 1/2 times 2, so we end up with VI, and then we multiply that by t, plus multiply the 1/2 through, we have 1/2 a, and then the two t's get multiplied together, t squared. And this is our second equation, which is on the AP equation sheet. So for the final one, again, we're going to start with the average velocity equation. So we have delta x equals 1/2 VI plus VF times t. And then we're going to substitute something. Well, here, there's a couple ways you can do it. I'll start with this. All right, hang with me for a second. If we take this equation here, which was our number one equation, and we solve for time, so we have t equals VF minus VI divided by A. And now what we can do, we can substitute this in for that value right there. And here's what we end up with. Delta x equals 1/2 VI plus VF times VF minus VI all over A. Now, it looks a little bit messy, but you can work yourself through here. You're going to end up with 2 times the acceleration times delta x equals VI plus VF times VF minus VI. Put the vector notation. All right, so basically we got everything. It took the acceleration out of the denominator, multiplied by both sides, and that's what we're left, and the 1/2 multiplied both sides by 2. And now we have this on the right, which we can FOIL, right? And once you do that, you end up with VF squared equals VI squared plus 2A delta X. And that is the third kinematic equation that is found on the AP equation sheet. Perfect timing. There you go.